Hello everyone. So first of all, my name is Abdul Rauf, and in this video we'll talk about convolutional neural networks. So basically, convolutional neural network or CNN are used for computer vision tasks. So what are computer vision? Well, computer vision is a computational method for analyzing and understanding digital images. Well, a famous data set for computer visions is known as the minist handwritten digits or numbers. So here you can see the example here you can see that someone wrote some handwritten characters from 0 to handwritten digits from 0 to 9. So here you can see some of this here. This is the known as a very famous data set for computer vision known as the miniest handwritten data set. So basically our computer didn't understand the images on letters. It only understands some numbers. So we try to convert these images into some numbers. Basically, what are these images? 0 9, what are these images? Well, basically these images are some like a grid. Now you can see a grid which has some rows and columns. Now you can see a grid of 28 by 28 pixels. So this is some grid lines, you can say. This is lines, and when we try to like assign some number, we add some color there. For example, if we want to add 2, we use like this, and if we want to add in the grid, we so basically colors, and these colors are also numbers. For example, like our computer represent them from the 0 to 255. For example, if we have black color, his value will be 0 from 255 scale. And if we have like white color, this scale will be 255 the full. And if we have like middle color like gray color, we will have the middle range. Okay, so these are the color we represent by the computer, or these colors are represented by the computers. So basically conventional neural or CNN is a neural network that uses conventional like the filters to filters we apply to the images, usually for analyzing images. For example, now let's see some structure of CNN. So the structures goes like this. First, you have some grid of numbers, like grid of lines with 28 by 28 pixels, and it has some numbers. And then we use some convolution, some filters, and then we get some like few filters we apply, and then we get some value, and then we use pooling. Pooling is like minimizing the images to some lesser pixels so that we can use them to flatten in our neural network, because the inputs of these convolutional 28 by 28 is very large, so we try to make it minimize it so we can use it. So we use pulling for minimizing, and then we use flattening so we can add them to it. So let's see what is the convolutional and pulling before going deeper to these structure. So convolution is like applying a filter, I already said, that adds each pixel value of each image to its neighborhood weighted according to a kernel matrix. For example, now let's see if we want to apply this. Now you can see on the left side, minus 1, minus 1, minus 1, minus 1, 8, minus 1, minus 1, minus 1. This is the filter we are applying to this matrix, 0, 0, 0 matrix by 3 by 3. And then we apply it like this. We multiply each with corresponding element, like doing some like dot product, but dot product are in vectors, but it is a matrix. So we apply some like you can say we applying a dot product in the matrix, which is not possible because this is not a concept. But I'm already let just take an example of like that. But what we do is like corresponding. We first multiply the corresponding number like 20 with minus 1, 20 minus 1, and then like this, and then we add them together and we get some value. So here we can get a value 0 because the numbers are all the same in the here 20, 20, 20. That's why we get a 0. If we get some like if the numbers were different and high like this, then we get a value of 19. So it makes some sense applying these filters. Okay, so this is the conventional, and now let's see what is pulling. Well, pulling is like reducing the size of an input by sampling from regions in the input. So basically there are many types of pulling, like max pulling, average pulling, and like that, but we see here the max pulling. So basically in max pooling you get first you try to like minimize the image like this 4 by 4 into 2 by 2. So first you take these four elements, and then we see which is the maximum one. You can see 50 is maximum, then we add the 15 here, and we see the next 4 by 4, and then we see which is the maximum one here, and you can see 101 110, and then we take 110. And in the third one you can see we go to the below line, and then we see the 4 by 4, and then see which is the largest one, maximum one, and we can see 20 is the maximum one, and in the last we see these four, and then we get the 14. Here the 14 is the maximum, so we get some input like this. So basically we minimize the 4 by 4 matrix into 2 by 2 matrix. Okay, so this is known as the pooling. So back to the this diagram. Now you can understand more conventional, like the conventional. What is conventional? It's the filter we apply, and in the pulling uh, we minimize the image from at 4 by like 28 by 28 by to 4 by 4 like this, or can we apply it 2 by 2 too. So we like minimize the image, and then we flatting, like we use them these layers into our new network now, as it is now simple. Sometimes we use multiple pulling or multiple conversion based on your CNN network. Okay, so now you have some question like how can we use how can we apply this in the code. So the code of this be may look like this. So first you do some processing, pre-processing here up there, and in the here you can use some neural network. For example, you use the sequential neural network, which will be like connected to the other neurons too, and then we use hierarchical layers toward conventional V2D. So it will use conventional network with the input like 28 by 28 pixels, and you can see here. After that, you use the max pulling like we already used. You can also use average pulling if you like, and then we use the max pulling of 3D by 2 by 2. So we convert the 28 by 28 into 2 by 2, and then we use the layers dot flatten, so it will flatten the layers into the new network. So here you can see after that we are using some compiler like optimizer Adam and loss like control crystropy, and then we are using metric like accuracy because the accuracy matters here. And then we are using like model.fit extend and widen the values of our training data set, and then we are using epochs like 10 epochs, so it will repeat 10 times, and then we are able to model with extend x test and y test. We are testing now on the x test and the y test, and then we are using verbose too. So after that we are using some length, and then we are saving the model because it's very useful because we trained our model on a CNN. Now it will get a good result, then we want to save that model so we can use in other models too. Okay, so yeah, this was a basic intro about the CNN. If you like it, that's good. So yeah, this was all. Thank you for watching, and I will see you in the next video. Bye and take care.